Welcome to the fourth lecture on Newton's laws. This involves two equations, but you're probably thinking they are the same as what we've had in the past. And what we're looking as centripetal force, okay, on here, and this, let's put a C there, and this is nothing more than the weight with our coefficient, the whole thing, but with the coefficient of friction added for this. Actually, it's almost a real world example. This other one is you're seeing weight here, but instead of accelerating straight as we did in lecture 2, we're moving in a circle because this is centripetal force again. I'll just put cent force. There's the C and the E. So we're putting these things, these equations together because of force. It's a force. And some of them, you might see a net force here in some books, but we're just going to kind of leave the net out. A clue for this one is your coefficient of friction. So if you see that in there, you know that friction is in there. And another key one is a radius. So we're going around a curve, as you know from Newton's laws, that everything wants to go to a straight line. So instead of trying to go in a straight line, we want to turn. So we got to deal with this. So a highway engineer has to look at these plus average conditions of that. So it says, what's the maximum speed? Yes, I know. You could say velocity. Then we got a 1,000 kilogram automobile. So there's our mass. Okay, there's a radius. Key word there. Okay, if the coefficient, okay, there's coefficient of friction, kinetic friction, we're moving, of course, and there's our number. So we're going to put these together. Equals mu mg. Now you're probably thinking, do I need to put in the mass? Depends on your instructor whether or not they do. Some people will go on and put in knowing I can cancel them out. But you notice in our perfect little physics world, to a point, we can negate this, but we actually in real life mass does play a little role in friction. And turning. So I'm just going to plug it in just to show you. And okay, it says the maximum speed, so I'm looking for the velocity there, speed or velocity. And let's see, the radius is 30. Now that's 0.9 times 1,000. And of course, G is 10 or 9.8, depending on your teacher. And so V is in meters per second. So we've got everything there. Here's another one, pretty much the same way, except I said, what's the diameter? Just remember that diameter is half the radius, or twice the radius, and mv squared over r. Okay, and then let's see, that's mu mg. Okay, make sure I have plenty of long lines. Okay, I've got a 55 kilogram. Okay, and don't forget the little square. Okay, the radius. And then, whoop, I don't know why I put that there. We don't need it, but we know this is 0.45, so it's kind of slippery. And 55 times 10. Sometimes I get a little carried away about going with lines. Now, if there's this pencil, that's the reason why we do our physics problems in pencil. We can erase, but to show you much better on the screen, that's the reason why I'm using a pen. So first you'd find the radius, we know in meters, and then you would take this to diameter. Let's look at the other one. Now you notice if we were using this is horizontal, but we're going vertical here. So we've got F equals mg plus mv squared over r. So it says the tension at the top. Oh, there's your note. Tension going up. Tension. Well, since we're at the top, let's do this correctly. So I got tension going this way, and of course I've got weight going down also. So we're looking for the force on this. So I'm going to put an F there. I've got a 2 kilogram mass times 10. Okay, let's put the line. Okay, I'm going to erase this for a minute. In other words, mark it out. We'll go back to it just a minute. 2, got a little carried away as usual. Okay, 10 squared over 1. And the force, you're probably thinking, is he going? I'm going to go back to it. Give me time. Okay, you're thinking, okay, do I add track? Okay. You know, take a moment, put it on pause, put something in your hand and swirl it. Twirl it around in a vertical direction. Don't try to hit anybody with it. Think of yourself. Now we're at the top. Does your object feel lighter or heavier? And I bet you at the top you're thinking, ooh, it feels light, because as we know, centripetal force is towards the center. So what I'm going to have to do is subtract these two, since it's going to feel light, so we're going to subtract these. Now, you might get a negative number here, because sometimes they'll say that this is first, this is second. They'll just switch. And some say take the absolute value, which in effect you are. But remember, at the top, it's going to feel lighter, so you're going to subtract the two numbers. And if we look over here, it says what's the tension at the bottom, and if you did this little experiment, okay, mv squared. Always start out with the plus in your equation, because you're not sure whether you're going to add or subtract. Now, they may say plus and put a little negative like you would do in your math class. So I've got the same thing. I've got 2 times 10. I'm going to skip here. You notice I'm getting a little better at this. But we're still, don't forget the square. Okay, we know force, that's what we're looking for, is in newtons. If you did your little experiment, you felt at the bottom, it felt like you were probably, if you were going real fast, almost pulled it out of your shoulder out, especially if you had something very heavy. So what is happening, your weight and your centripetal force are added together. So we're going to add these two. And then just real quick calculation. And the last two, here's one. Now when you're doing this, okay, this is so as to not to break the rope. Think about it. I don't want to break it. So as to not to break, so what I need, least, which is the top, or most at the bottom. Okay, let y'all figure that out. And this one would be this. They could negotiate curve 20 meters per minute. Not that fast, but so we can figure out a kinetic friction. So this is pretty much it. Work out the rest. Remember, if you have any questions, don't hesitate to contact me or your